So here we go. This is just a practice problem. So pause the video, try it yourself, see if you can take yourself through the steps, and let's see if we can find something. Now, before you pause the video, I just will point out, notice this function, this system of equations are in 3 dimensions, meaning we couldn't graph these. So some people are asking, why not just graph and find the shaded regions of everything? Well, unless you're really good at drawing 3D, you can't do this problem. And then if this was a 4th dimension, good luck. That ain't happening. So this is where the method comes into play. Why we want to do this method, why it's superior, is this helps us solve problems that we couldn't just graph, shade, and test corner points. Okay, pause the video, give it a shot. Okay, here we go. Step 1. Take your objective equation and make it so you are equal to 0 and your p has a positive leading coefficient. Check. Next, step 2. Take each of your constraints and change them so that they are equal signs using slack variables to bring them up to equal. Okay, so I had to add q because it was less than or equal to, so plus a number to equal 3. All right, so the next one, x plus 2y plus z. Now I can't add the same slack variable for this one because I don't know it's the same amount as the previous equation. And similarly here, whoops, come on, x plus y plus qrt, why not? Equals 5. And again, the slack variables, you could be using lightning bolts and happy faces. It's just it's a garbage variable for the moment. So don't worry about it. And I guess I will emphasize, is this a standard simplex problem? What is the checklist? Number 1, it's asking for maximization. Good. Got it. Number 2, so number 1, max, yes. Number 2, all of them are less than or equal to, check. 3, all of our variables are greater than or equal to 0, check. Okay, so we're good on standard simplex. And like I said, we're not going to try and trick you on this first section, but just want to get you in the habit of looking. So there we go. Okay, so we got our all of our equations set up for matrix format. So now let's start subbing things in. So I'm going to have what variables? X, Y, Z, Q, R, T, P, equal sign. So notice I like to label them at the top of my matrix so I don't lose track of what stands for what. Okay, so now my red equation, my red constraint would be 1, 1, negative 1, 1, 0, 0, 0, 3. Then we've got 1, 2, 1 for the blue equation, 0, 1, 0, 0, 8, 1, 1, 0, 0, 0, 1, 0, 5. And then the objective equation always goes at the bottom. Negative 7, negative 5, negative 6, 0, 0, 0, 1, 0. All right, there we go. So we're all set up. We're ready to start rocking and rolling. So now I want you to be able to go through the process, selecting your pivot. So what is that thought process? Look for the largest negative number because that is our steepest slope. So that would be negative 7. So I'm going to go in the x direction, but I need to stop at my first x intercept. So I do that by finding the ratios. 3 divided by 1, 8 divided by 1, or 5 divided by 1. So all 3 of these equations have x-intercepts in 3 dimensions, for whatever that means, but we want the closest one, which would be 3. That would have the closest intercept. So our pivot will be right there. All right, so we've selected our pivot. We are now going to walk in the x direction. So our row operators would be, we have to use row 1 to get zeros below it. So my row operators are going to look like, I need negative row 1 plus row 2 to make a new row 2. I'm going to need negative row 1 plus row 3 to make a new row 3. And I need 7 row 1s plus row 4 to make a new row 4. And if you want to do those by hand, knock yourself out. But please, do not spend a ton of time trying to do that. Just use the website I provided for you to help you with the pivots. You will not be required to do it on a test. Okay, I'm going to bring up that website. Okay, so I typed everything into that system. I did my pivot in the top left-hand corner, and I got the following matrix. All right, so now we ask ourselves, are we done? And we say no. I still have a negative value in my objective. So therefore, we repeat the process X, Y, Z, Q, R, T, P equal sign. All right, so here we go. We say, all right, I need a pivot in the Z column. So now I need to check for which equation do I run into first? Well, 3 divided by -1 is -3. So that one gets tossed because we don't want negative intercepts. We only want positive. So then the next one would be 5 divided by 2, which is, which is 2.5. And then we have 2 divided by 1, which is 2. So 2 is smaller than 2.5. So this z-intercept comes up first. So we're going to pivot when we run into that equation. So here we go again. I'm going to click into that matrix. And so I didn't show it on camera the first time, but I'll see if I can show it this time. We're pivoting in this column, the Z column. So I'm going to click on that cell to pivot in. I click pivot. And now I rewrite down my matrix again. And you'll notice here, I have another pivot here down. I'm going to pivot because I have another negative value. And so you could technically start just working from here to get to your answer. But I just need you to write down the matrices so I can verify you're doing what you know what you're doing. But if for your homework, if you have this down, the key things that I want to make sure you know how to do is I want to make sure you know how to correctly select your pivot, and I want to make sure you know how to do the row operators. So could you look at this and tell me what would you do to get the zeros above and below? So I take row 3 plus row 1 to make a new row 1. I would do -2 row 3s plus row 2 to make a new row 2. And then I would need 13 row 3s to make, plus row 4 to make a new row 4. And that would be my math. Okay, so now we did our pivot. So let me write down our new matrix. Okay, so as we said before, I've copied down my new matrix, and we said there's still the negative value in the objective row, which means we check our ratios again. We're saying, okay, so 5 divided by 0, well, that is undefined, so we just definitely cannot pivot there. And then we have 1 divided by 1, which is 1, so that's valuable. And then 2 divided by -1, which is -2. Throw that out because it's a negative value. So there's only one potential place we could possibly even pivot, and it's right there. So now we do this again. We say, okay, we're going to pivot here. So the top row, row 1, already has a 0, so we're done there. So now I'm going to do what? Let me erase that. We're going to do row 2 plus row 3 to make a new row 3, because 1 plus -1 makes 0. And then we're going to need 6 row 2s plus row 4 to make a new row 4. And remember, we're just doing elimination technique. So this is the same thing from Gauss-Jordan. There's nothing magical happening here. All we're doing is finding intersections of lines because we're just moving around to different corners. All right, so here we go. And I'm going to see, and you could see it straight from here. There's the -6. So I'm going to pivot here on this 1. That was our pivot. And voila. So now when you look at our objective equation, you will see we have no negative numbers. So I've copied down that matrix, and we can see, again, no negative numbers down here in our objective, which means we're done. So now let's read our answer. Remember, this is X, Y, Z, and these are garbage variables. They're slack variables, but I used, so I'll fill them in, Q, R, T, P equals. All right. So now remember, any value that has lots of numbers, that's just might as well be 0. So Y has lots of values, so we're going to call that 0. This whole thing goes away. Z we're going to keep, Q we're going to keep, R has many values, so that's going to become 0. T becomes 0. And so now we read our rows. So as we read across here, this is going to be X plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 equals 5. The second row is going to end up being Q equals 1, but Q is a slack variable, so I don't care. All right. The last row here is going to end up being Z equals 3. Keep that one. So then what is the other variable we do care about? Well, our original equation had x, y, and z. Well, we have a value for x and z, but what is y? Well, y is just 0. So therefore, we have our order triplet now. 5, 0, 3. So I know my maximum is going to occur at 5, 0, 3. But what is that maximum? Well, that's what comes from the last row. That's what comes from the last row. So we're just going to say this is P equals 53. So therefore we know we have a max of 53. And that is it. All right, stay tuned for the next video where I will go over the website that helps you check your work.